reflective IR proximity sensor. It is follow-up video for my last video number displayed on the screen, IR LED transmitter and IR receiver. If you have not watched that video, I will suggest to watch it. We will use the same configuration to make this proximity sensor. IR LED will transmit IR light. Any object in that area will reflect that IR, and phototransistor will receive that reflected IR. Using this potentiometer, we can adjust the sensitivity of the comparator. We can adjust the detection area as per our requirement. Let's suppose it is triggering at this point. If we want to set it here, we will adjust from this potentiometer. Assalamu alaikum wa rahmatullahi wa barakatuhu. I am your host Muhammad Ashraf and I welcome you on my YouTube channel. If you are new to my channel, subscribe it. If you want to watch my videos in future, press bell notification for all so that you will be notified for my future uploads. IR LED. I used 5 volt power supply. I used 5mm IR333 LED. This is part number. I connected current limiting resistor. In last session I used 150 ohm. But to make it more safe, I used 220 ohm resistor here. When we will connect in this configuration, it will transmit IR. Phototransistor. Any part number that is available with you. PT204, PT333 6B or 6C, PT334 6B or 6C, 3mm or 5mm, kilo ohm resistor. This time I am connecting with the same power supply, 5 volt power supply. Now it is transmitting IR, but there is no object in this zone, so there is no reflection on the phototransistor lens. When any object will reach in this surrounding, that will reflect IR. We can use it in different projects. We can use as a motion detector, obstacle detector, level detector, IR reflection sensor, proximity sensors, to count the gear teeth, whatsoever. I am using LM358. I connected this signal to non-inverting pin number 3. Pin 4, ground. Pin 8, positive 5 volt, the same positive 5 volt. I connected 1 mega ohm resistor as a positive feedback resistor to make comparator, so that it will provide clean digital output. I used a potentiometer 10 kilo ohm to adjust the sensitivity. 1 mega ohm. I am using panel mounted potentiometer. You can use PCB mounted potentiometer. To make this signal visible, we connect LED 1 kilo ohm. This is inverting input, that is pin number 2. The circuit is ready. To save the time, I assembled the same circuit on the project board. Any object when it will reach at a specific distance, I covered the optical lens of phototransistor by installing a heat shrink tube, black colored, and I covered by these heat shrink tubes so that its IR will not make any confusion for this phototransistor. Any reflected energy, IR energy, that is coming back to the optical window of this phototransistor will make an operation. We can adjust its sensitivity by adjusting this potentiometer. Let's suppose we have any object at this distance. If I want to turn it on here, we can adjust the sensitivity. Let's suppose I want to turn it on here. I will adjust it. We can calibrate it. Moreover, direction of the IR transmitter and direction of the lens of this phototransistor is also involved in calibration and its adjustment and detection. Now the transmitter and sensor are in horizontal direction. It will convert the direction in this way. In that condition, it will detect any gear teeth to sense the rotation and sense the RPM. If we paste a small reflective sticker on any shaft and we place this proximity sensor in front of that shaft and we adjust the sensitivity, that non-reflecting area will remain silent. When reflector sticker will reach here, reflecting tape will reach in front of this proximity sensor, it will create pulses. So we can count the pulses using this idea. When any object is coming closer to this sensor, it will create signal. So we can sense position of any moving object, level detector, gear teeth counting, shaft position rotation, moving object, level sensor. If you have any other idea to use this project, or you can give a new name to this project, I will invite you to write in the comments. If you think this video is informative, share with your friends. If we see the function of this circuit, we provided 5 volts to the IR LED 220 ohm resistor. It will allow IR light. When IR light is emitted from here, it will go to any object that will reflect to the lens of this phototransistor. IR line of sight and phototransistor line of sight must be in parallel, and its focusing is very important, that its look angle and its look angle must be at the same point. When reflected IR will reach to optical window of this phototransistor, it will conduct. When it will conduct, it will provide voltage level here. Before this, when there was no IR, it was working as an open circuit. This was at low level. But now, when it is conducting, it received IR. What is the intensity of the IR? That will cause to change its biasing. It will cause to flow the current. That voltage will reach here at pin number 3. Pin number 2 is inverting input. It is working as a reference pin. What is the distance that will reflect IR to the optical window? It will conduct. What is the level of conduction? It will create voltage here. Pin number 3, non-inverting input. That is error signal. Pin 2, reference signal. Pin 1 is output. We connected a 1 mega ohm resistor between pin 1 and 3. If pin 3 is less than pin number 2, output is low. When it is low, this positive feedback will force this comparator to stay in off condition. When error signal, that is pin number 3, will increase than pin number 2, it will provide high output. This high output will force this operational amplifier to work as a comparator, provide a clean digital output. Either it is low or high. We can adjust conducting point of this comparator by adjusting this potentiometer. This time it is conducting here at this distance. If I will adjust it, we change its conducting point. If I adjust it to sense more closer, now its trigger point is here. Now it will trigger at this distance. So using this circuit, we can detect the position of any object that is coming closer to this circuit. This is first use. Second use, if you want to use it as a level detector, the level is increasing. When level will reach at the specific point, it will give light. If you want to find any falling object, it will give signal. If you want to sense any horizontal movements like this from any direction, from this side or from this side. If you want to count the gear teeth, we need to place sensor and transmitter in vertical direction in front of gear. When gear teeth will come in front of the sensor and we adjust the sensitivity, when gear teeth is in front of the sensor, it will give signal. When there is gap between gear teeth, it will give off signal. So we will find pulses here. We can count the number of gear teeth. Can you suggest any suitable name for this project or any other use? I will invite you to write in the comments. If you think this video is informative, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.